Alright gang, whip flash. Neiman, just do your best. Let's see some film. Little trouble there. Let's bring it back up from 17. Now go by tempo. One more time. Rushing. Come on, one more time.
Wow, I cannot believe Fletcher threw that shoebox at Neiman that has a horizontal position that can be modeled by the set of parametric equations x of t equals t squared plus 2, y of t equals cosine of pi times t minus 1, where Neiman's has a horizontal position that can be modeled by another set of parametric equations x of t equals 3t, y of t equals sine of pi times t over 2, where both sets of parametric equations are defined in feet and t is defined in seconds. Using this, we can find at what time the shoebox will hit Neiman, along with the speed it will be at that moment when it hits Neiman, as well as the total distance it traveled from when it was thrown to when it hits Neiman. So in order to find when the shoebox would hit Neiman, you want to look at both functions, x function, and you want to look at these as a set of equations, and you want to do the same for the y value. And then you need to find a t-value that would solve both systems of equations. And so it'd be difficult to find a t-value that solves this algebraically when these two are equal. But if we just take this function and this function and you add them together and then you subtract 3t, you get a simple quadratic equation that can then be factored. So now what we know is that at 2 seconds and at 1 second, both objects have the same x value on the horizontal plane. And so now what we can do is we can just plug that in after we set these equations equal. And we can see that if you plug 1 in, you get sine of pi halves, which is 1. And then you get equals cosine of pi, which is 1. But then you subtract the 1, because that's in the equation. So you get 1 equals 0. So 1 does not satisfy this. However, if you plug 2 in, you get sine of pi is equal to cosine of 2 pi minus 1. Sine of pi is 0, cosine of 2 pi is 1. 1 minus 1 is 0. And you can see that this satisfies both the x functions and the y functions, meaning at 2 seconds, both objects are at the same point. So this is when the shoebox would hit Neiman at 2 seconds. So now that we know when the points touch, now what we can do is we can find the speed and the distance. And we're only going to do this for the shoebox though. So the formula for speed of a parametric equation is the square root of dx over dt squared plus dy over dt squared. And so dx over dt simply represents the change in x over t, which in our case is time, and same with dy. So all you have to do is take the derivative of the function of x of t and y of t, and the x function is t squared plus 2. So now you can just use power rule to get 2t, because the derivative of any constant is 0. And since we're at 2 seconds is when the shoebox hits Neiman, 2 times 2, 4. Now for the y function, it's a little bit harder. You have to do chain rule, but you end up getting negative pi sine of pi t. The derivative of cosine is negative sine, and you're doing a chain rule, so you take the derivative of what's inside, which is pi times t, so you would get pi. And at 2 seconds, you would get 2 times pi, the sine value of 2 times pi times negative pi, but sine of 2 pi is already 0. So now you just take the square root of these values squared. So 4 squared, which is 16, and there is no value for that, it is 0. So the square root of 16 is 4. It would be plus or minus 4, but you can't have a negative speed, because speed doesn't indicate direction, that would be velocity. So when the shoebox hits Neiman, it has a speed of 4 feet per second. So now finally we can find the total distance the shoebox traveled from when it was thrown to when it hit Neiman. It hit him at 2 seconds, so you'd be integrating from 0 to 2. The distance formula, like any equation, is just the integral of the speed formula. So we plug in our dx over dt and dy over dt, just like we did to find the speed, but we leave the equations as they are. And it would be very difficult to integrate this by hand, so you'd have to use a calculator, but you would get 5.229, which that means the shoebox traveled in total 5.229 feet horizontally before it hit Neiman.
So why do you suppose I just threw that shoebox at your head?
I don't know.
Yes, you do.
Tempo?
Were you rushing or were you dragging?
I don't know.
Start counting.
5, 6,
In 4, damn it!
1, 2, 3, 4. 1, 2, 3, 4.
Rushing or dragging?
I don't know.
Start counting.
1, 2, 3, 4. 1, 2, 3, 4.
Rushing or dragging?
Rushing.
So you do know the difference. If you dare sabotage my van, I will obliterate you. Now for the last time, are you a rusher, are you a dragger, or will you be on my flipping time?
I'm gonna be on your time.
What does this say?
Corno equals 260.
Count it.
1, 2, 3, 4. 1,
Oh
2.
my god, I didn't know they allowed idiots into Schaefer. Am I supposed to expect you can't read tempo? Can't even read sheet music? What does this know?
8th note.
What does this know?
16th note.
So I read this music.
Ba, ba, ba.
Are you an a cappella group? I'll make hits. You must be upset. Are you upset?
No.
So you don't care about any of this?
I do care.
So are you upset?
I'm upset.
Say it so the rest of the band can hear you.
I'm upset.
Louder!
I'm upset.
Carl, start practicing, Neiman. Whiplash.